Welcome to Computer Vision Streams. I'm your host Anton, and today we will see how to use Yolo model in DeepStream pipelines. We will follow the guide from Ultralytics documentation for NVIDIA Jetson, but we will try to run our pipeline on the normal desktop computer with GPU card in the Docker container. Let's see what we need for that. Let's build our DeepStream image from NVIDIA DeepStream 7.0 samples multi-arch and install additional dependencies plus Conda to be able to configure the environments. Next, we allow our container to display windows and we run our image. First thing, we will install Ultralytics with specific export functions to be able to convert PyTorch .pt files to ONX files that later we will be able to convert to Tensor runtime engines that we will use in our DeepStream pipeline. So for that, we created an environment with Python 3.10 because 3.12 was a little bit too new for Ultralytics to work properly, and we just cloned Ultralytics repository and install with this command. Next, we need to clone this repository that will contain all the default configurations for Yolo models and also the post-processing functions and the engine builder functions. After that, we can copy the export script from this repository to Ultralytics repository. Next, go to Ultralytics repository and download weights from the release page of Ultralytics GitHub repository. We chose YOLOv11 model, which usually gives a nice, good first impression and correct trade-off between latency and performance. Next, we need to export our PyTorch model weights file to ONX file. For that, we will use export YOLO11.py with these parameters: model weights, ONX offset, default size that we increased from default 640 to 1280. Then we will ask to simplify our ONX file to make some optimizations and export with dynamic byte shape. Script will generate ONX file and also labels txt for our DeepStream configuration that we can copy to DeepStream Yolo folder. Next, we will need to build a shared library in order to provide post-processing functions for DeepStream. For that, we will have to define a couple of environment variables to communicate the version of CUDA. In our case, it's 12.1, and the library path for specific CUDA libraries. Next, we can use a make command to build our shared library in NVIDIA Infer custom implementation Yolo folder. Afterwards, we will need to change a couple of configurations in the DeepStream Yolo folder in order to choose our ONX Yolo file as a model, and then first time when we will run our DeepStream application, it will take this ONX file and it will generate model engine. Afterwards, for the same hardware, you don't have to regenerate this file once again. You just point model engine file to the engine that you would like to use, and the pipeline will start immediately without waiting for conversion from ONX to Tensor RT. Next, we will use sample DeepStream application just to make sure that it is working. And we will need to change our primary inference engine config file. 2.2 config info primary YOLOv11. Afterwards, you will be able to execute the DeepStream app, providing this DeepStream configuration. If everything is working fine, you will see the FPS and you will see that our model S could perform at 70 FPS per second, which is an expected performance. Next, you can use this engine file and configuration file in your custom pipeline. The example would be as follows. We have our custom pipeline that we can run with GST parse launch. We use NVIDIA source bin with file input, and we pass our txt configuration file that we used in the previous example. Next, you can use a couple of commands from the README to build our old DeepStream application. Old is in comparison to a new version of a service maker library that could be used to build applications in a more C++ way. And after some time, you will see that NVIDIA's logger will report also 65 or 70 FPS per second. And then you can modify this simple pipeline to suit your needs. If you want to check the output of the pipeline and that you correctly configured your Yolo inference configuration, you can use NVIDIA Glass Sync to output predictions in a separate window. And you can make sure that your pipeline is working well and produce correct detections. If you take a look at our Yolo inference configuration, we will see that there is support of CPU and GPU parse VBox functions. In the next video, we will see what will be the difference in the performance between different implementations of Yolo and how to push the performance and latency of different Yolo models. If you like my videos, please subscribe to this channel. If you have any questions about DeepStream, you can connect me through LinkedIn or in the comments down below, and I will see you in the next video.